All right, welcome back. Day 7 notes, solving some more logarithm equations, okay? We're going to step it up a notch here and put it all together in this lesson. So, first example, this is one that you guys have seen before, right? If you only have one log, these problems are pretty straightforward and easy, okay? Because if you think about it, all I'm going to do is take this and write it in exponential form. So 2 to the 5th power should equal x minus 6. 2 to the 5th is 32, so x is 38. So that's a pretty straightforward problem. Now example 2, if I look, I have log base 2 of x plus log base 2 of 3 equals 3. With this problem, what you have to understand is you have this log plus this log. And if you think back to a previous lesson, well, how could I rewrite this as a single log? Well, if these logs have the same base and they're linked by addition, that means the product of 3 and x were broken up. So we can rewrite this as log base 2 of 3x equals 3. Now I can go ahead and solve this the way I solved the previous problems. 2 to the 3rd power is equal to 3x. So 3x is equal to 2 to the 3rd is 8. I can divide by 3, and x is equal to 8/3. So you have to use the properties of logarithms first, and then rewrite it in exponential form, and then go from there. So the next one, example, it should be 3. If I look at this, I have log 2x plus log of x minus 5 equals 2. I do see the addition, so I'm going to combine these, or condense this, to be 2 log of 2x times x minus 5 equals 2. But now here's where the algebra gets tricky. I know I have to do, if it's just plain log, remember that's base 10. So we're basically doing 10 to the 2nd power is equal to 2x times x minus 5. So now I have to distribute the 2x. So I would get 2x squared minus 10x equals 10 squared is 100. Anytime I have an x squared term, I have to recognize that I have to solve a quadratic. So I can either use quadratic formula or I can use the factoring method. But my first step either way is to set this equal to 0 by subtracting 100. Now, if I look, there is a greatest common factor of 2 here. So if I factor that out and I divide everything by 2, I would get 2 times the quantity, x squared minus 5x minus 50 equals 0. Now, what numbers multiply to give me negative 50 and add up to give me 5? That becomes 2 times. It's going to be x minus 10 times x plus 5 equals 0. The reason it's x minus 10 and x plus 5 is because, right, negative 10 times 5 gives me negative 50, and negative 10 plus 5 gives me negative 5. So now I'm going to take the two variable expressions and set them equal to 0. X minus 10 equals 0. X plus 5 equals 0. And x equals 10. X equals negative 5. Now the solution in this case is x equals 10. Because if I plug that in, 10 is part of the domain. But if I plug negative 5 in, is it possible to do the log of negative 10 when I plug that back in? No. So this is what we call an extraneous solution. A solution you get, all right, but it doesn't work when you plug it back in. Example 4, very similar. Okay, but here's the thing. Here I have subtraction. So what do I have to do with these when I condense this logarithm? It's log base 2 of x minus 1 over x plus 2 is equal to 2. Now I can go through my process. 2 to the second power is equal to x minus 1 over x plus 2. But the question is, how do we solve this equation algebraically? The way I look at it is I'm going to set it up as a proportion. I have this fraction equal to that fraction. And if you remember, we can cross multiply here. 4 times x is 4x. 4 times 2 is 8 equals x times 1 is x. Negative 1 times 1 is minus 1. So now I would solve this equation. Subtract x, subtract 8. 3x is equal to negative 9. X is equal to negative 3. But we do have to plug this in and check it. And when I plug it in and check it, log base 2 of negative 3 minus 1, is this going to be possible to do? No. So the thing is, this is not a solution. And it ends up being that there's no solution to this problem, because if negative 3 doesn't work, none of it works. And the last example here. I see subtraction, so I'm going to rewrite this as log of x over 6 equals, if this 2 is out in front, I'm going to bring it up and make it an exponent. And 4 squared would give me 16. So now, if I have a log with the same base equal to a log with the same base, these have to be equal to each other. So x over 6 equals 16. How do I solve for x here? Multiply by 6, and x is equal to 96. So with these, you're working backwards using the properties first, and then what you know and how you know how to solve these logarithm equations. Go ahead, try the homework, and let me know if you have any questions.